Objective 4A, that's confusing. I think it's objective 3, the following, and this is the next objective after objective 2, which was solving quadratics by finding the greatest common factor. This objective is solve quadratic equations by using the MACAB T-chart. So I think on your pacing guide, this is objective 3. I made a little mistake there. Alright, so using the MACAB T-chart, that's just a tool that I use to solve quadratic equations when all of the terms, the A, B, and C terms, are present. So that's what I put in blue first. You use this technique when A, B, and C are all present. And this is important to note as well. This process is going to be when A equals 1. There is another piece to this process. The next objective is going to be the same technique, MACAB T-chart, but it's going to be when A doesn't equal 1. All right, so that's the key difference between these two factoring strategies. Same thing in the previous video as this one. I'm going to do an example, number 12 up here, and then I'm going to ask you to try your own example within the video, number 11 down on the left-hand side there. So you pause the video, try that one, and then unpause the video to check your work. Alright, this factoring strategy is a little bit different. It is a process where you kind of come up against some guessing and checking. Because you have to find, it's like putting together a puzzle. You have to find numbers that multiply to one number and add to another number. Alright, so the biggest frustration with this objective is just that process. You might come up against like, I can't find any factors, I don't know what to do. It's just potentially that you haven't tried every option that exists for this quadratic function, for the given quadratic function you're working with. Alright, so step 1 within this process is the same as the first objective. You have to get it into standard form with the right side equal to 0. Now this is a little bit different because, like I said again, all the terms, the A, B, and C terms, are present. And if you remember, standard form is ax squared plus bx plus c. So it's important it's going to equal 0. It's important to know the order, the A term, then the B term, then the C term. Because there will be times when you have to move a B term, like in the example I'm going to do. And then there will be times where you have to move a C term, like in the example you're going to do. And then there's going to be times when you have to move multiple terms. So the end goal in this step is just to put it in standard form after you move pieces around. So if you notice, n squared plus 24 equals 10n. This is the A term, the quadratic term. And 24 is not the B term. 24 is the C term because the C term is always just the number, or the constant, all right? The C term is always just the number, so this is the C term. So if you notice, they're out of order. I have to put them in order. And that means then that it equals the B term, negative 10n. And the B term is always the linear term, the variable with the power of 1. So I need to move the B term over. So I'm going to add 10n to both sides because it's a negative 10n. I'm just going to add it underneath the quadratic equation on the left-hand side. Now, cancels out, it's going to equal 0. And on the left-hand side, 10n doesn't have a term to combine with. There's no other n power, or n to the power of 1 on the left-hand side. So this is where I just write it in standard form. And again, the 10n has to go in between the A and the C terms. So I'm going to write n squared plus 10n plus 24, my C term. And at this point, I am done with step 1. I've stuck the B term in its home, its original home, in between the A and the C term, and I wrote it in sequential order, the power of 2, power of 1, and then the C term equal to 0. So I have standard form right here. I'm going to write SF. It's going to stand for standard form. Now the process is I'm going to set up the MACAB T-chart and eventually in step 3 write it in factored form. So for step 2, this is the new learning. I'm going to write MAC, and I'm going to tell you what that stands for in just a second. Make a little T-chart, and then write AB. So MAC stands for multiply A and C together. That's an and sign in between A and C. So you multiply the A and C term together. In this case, because A is 1, it'll always be the C term, but there will be cases when A is not 1. So when you multiply the A and C term together, that goes below MAC. So let's do that right here. The A term is 1 because there's no number listed. The C term is 24. 1 times 24 is 24. Alright, so I multiply the A and C term, and then AB stands for add to B term. And in this case, all I put underneath AB for now is whatever the B term is, and it's 10. Just the numbers, not the variables. Remember the coefficients in front. So I have set up my MACAB T-chart completely at this point. I wrote MAC, I wrote AB, I wrote 24 and 10 below their needed spots. Now, to reference, MAC and AB is just a clue for you to kind of think of what to do, all right? Because this is the second part of this step. I need to find numbers that multiply to the A and C term, which in this case is 24. So I need to find factors that multiply to 24 and then add up to the B term. That's why I put AB over here, add up to the B term. So I need to find factors that multiply to 24 and add up to 10. All right? In this process, this is the most frustrating process because it's just guessing and checking. Unless your brain can see it right away, numbers that multiply to 24 and add to 10, you're just going to have to go down the list, all right? I would start always with the factor of 1 and the number itself. 1 times 24 is 24. 1 plus 24 is not 10, all right? So we're just going down the line. After 1, I would try 2. If 2 isn't divisible into the MAC term, then move on. It doesn't work. But in this case, it is. 24 divided by 2 is 12. 2 times 12 is 24. 2 and 12 are factors, but they do not add up to 10. A certain negative combination does, but that still wouldn't work. Now let's try 3. 24 divided by 3 also works. It is 8, but 3 plus 8 doesn't add up to 10. Finally, let's try 4. All right, 24 divided by 4 is 6. So 4 and 6 are factors of 24. And if you notice, 4 plus 6 does equal 10. All right, so I have found my factors. Now I'm going to have you can either do it that way mentally, or you can use your calculator to help you find the factors. So I'm going to show you that really quick as well. All right, so I have pulled up a calculator. This is just a process to find the factors I've written in blue: 1, 24, 2, 12, 3, 8, and 4, 6. A little bit easier with your calculator. If you pull up y equals, and you put the MAC term, whatever you have, so you'll still have to set up the T-chart, but whatever you have for the MAC term, you put that first, 24, and then you divide it by x. It's just a trick from the calculator, all right? And then I'm going to hit second graph to bring up a table. If you notice, there are my factors. The factor of 1 gives me a partner of 24. Factor of 2 gives me a partner of 12, 3 gives me 8, 4 gives me 6, 6 gives me 4. All right, so that's just a way to look for combinations of numbers that you can use to multiply to the MAC term and add to the B term. So again, what I did, I went into y equals, I put in the MAC term, which is 24, and then divide by x. So whatever the MAC term is, divided by x, and then hit second graph to bring up the table. And that's your list of factors as well. It's just a quicker way for you to look through some numbers and then pick the right ones. Now, it is important to note, it didn't happen in this case, but there will be times when you have to make one of the factors negative or both of the factors negative to get it to multiply to the given MAC term and add to the given A term. You'll just see that within your practice. It's going to take some just working through it to figure that process out. But there will be times when you have to make them negative. This isn't one of those times. So I am done with step 2. I have set up the MACAB T-chart and found the factors. They are right here. Now, I'm going to put step 3 over here. I'm going to write in factored form. So when it's a quadratic trinomial, when the A, B, and C terms are present, I'm going to write 2 binomials. The standard form becomes factored form and it becomes 2 binomials. I need to give myself a little bit more space, so I'll write it down here. 2 binomials, all right? Each binomial gets a variable. In this case, it's n. And then each binomial gets the factor. If you notice, it's a positive 4, so I'm going to write plus 4. And then it's a positive 6, so I'm going to write plus 6. If If they were negative numbers, I would write n minus 4, n minus 6. And I'm going to set the factored form equal to 0. Now it's important to note, this is factored form. Please write that down. Factored form is the same as standard form up here. It's just written in a different form, and from factored form we can go ahead and use the product property and find each of the solutions that exist for this given quadratic function. Alright? Now for step 4, that is that process. I take each factor, n plus 4. It becomes free from the parentheses when I set it equal to 0. So n plus 4 equals 0. And n plus 6 equals 0. And then step 5, I just solve each of the factors. In this case, it's really easy. At times, again, it won't be as easy and it'll give you fractions, but for this case, it's pretty straightforward. I subtract 4, so n equals negative 4 over here. And I subtract 6, n equals negative 6. That is technically step 5, and that is my answer. Now, again, it's important to note, if I were to graph this original quadratic function, n squared plus 10n plus 24 written in standard form, it would hit the x-axis at negative 4 and negative 6. So there's technically a relationship. It's n plus 4, n plus 6 in factored form, but the solutions are n equals negative 4 and negative 6 because you have to solve them. And so that is something, that's like the grand idea of this whole process. If I graph it, where does it hit the x-axis? And can I find the location of where it hits the x-axis algebraically, which we just did. So at this time, please pause the video and try your example on your own, and then unpause it to check your work. At this point, you should have paused the video and tried number 11 on your own. First step, I wrote it in the standard form. Second step is I set up my MATLAB T-chart. A times C in this case gives me negative 42, and my B term was a negative 1. It wasn't written, but I can assume if there is no number before a variable, it's always 1. In this case, it's negative because it's being subtracted. Now, finding the factors is a little bit trickier here. I just went down the line. 1 times 42, those two factors do multiply to 42, but they don't add up to negative 1. 2 and 21, same thing, don't. 3 and 14, don't. 4 is not a factor, 5 is not a factor because it doesn't divide into a whole number. And so I came across 6 and 7, alright? 6 times 7 is 42, but if you notice it has to be negative 42. So because it has to multiply to a negative 42, I had to make one of these two numbers negative. Alright? 6 times negative 7 does equal negative 42. And 6 plus negative 7 equals negative 1. So if you notice, if I would have made the 6 negatives, negative 6 times 7, negative 6 times 7 still equals negative 42, but negative 6 plus positive 7 gives me a positive 1, so that wouldn't work for the situation as well. So this had to be my set of factors to satisfy both conditions. Multiply to the C term, add to the B term. Now, step 3, I wrote it in factored form. Set it equal to 0. Step 4, I used the 0 product, set each factor equal to 0, and I solved, and I got my solutions. A equals negative 6 and A equals 7. If your work doesn't match mine and you didn't get those answers, please raise your hand and I will come check it. Thank you for watching.